All right, welcome back to pre-calculus. So last time we talked a little bit about reference angles and where they were and what we're going to do with them and how different pieces lie on different parts of the circle or parts which quadrant things lie in. We're going to continue to talk about that with trigonometric ratios. Okay, let me go ahead and share. Okay, so what we're looking at here, let's start with a brand new piece of paper here. We have secant of 25 pi over 6. Okay. Here you go. Excuse me for a minute. I hear a dog whining. Well, I don't know. Okay. So we're trying to figure out what is the secant of this angle. Okay. So the way we're going to do this, 6 goes into 25, right? 4 times with one remainder. Okay, so you have to be a little careful because all the way around is like a 2 pi sort of ordeal. So that's going to be 12 pi over 6 to go one revolution because that's 2 pi. We go another revolution. That's going to double. We're going to have 24 pi over 6. So we have to go one more. Not one more revolution, but one more pi over 6. So that's here. So our reference angle for this, right, this is pi over 6. Okay, so my reference angle is pi over 6. Okay, because we've gone around twice and we just have pi over 6 left over. So we have to figure out the secant of that. Okay, now you know the secant values if you don't remember them, right? The secant is 1 over cosine, so secant of theta equals 1 over cosine. And do you remember doing this? Do you remember saying 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, here is my sine of an angle and my cosine of that angle. So sine was square root of none over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Cosine counts down. Okay, so here we have square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of none over 2. So the pi over 6, right, this was 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0. Okay, square root of, or the cosine of 30 degrees, pi over 6, is square root of 3 over 2. Okay, so the secant is square root of 3 over 2, reciprocal. So that is equal to 2 over root 3. And of course, your book is going to insist, actually every book is going to insist, it's not yours, okay, that we are going to rationalize the denominator. So that's 3. And we have 2 root 3 as my value. Okay, so that's the secant of pi over 6 is also the secant of 25 pi over 6. All right, first quadrant, so everybody's positive. We don't have to worry about that. But this is going to be 2 root 3 over 3. Okay. Double check I got the right thing right now. I do. We're good. Okay, set and ready to go. There was a problem with this assignment. Oh, we are out of time. All right. Let me pause. All right, I have to restart my Connect Math here. So now they give me a different problem, of course. So we have secant of 5 pi over 6. Well, it's not really that big of a deal. I'm sure we could all use a practice. So where's 5 pi over 6? Right, so it's 1, 2. This is 3 pi over 6 because that's 90 degrees, right? That reduces to pi over 2. 4, 5. So 5 pi over 6 right here. How much more do we have to go to get to the horizontal? 1 pi over 6. So this, what we're looking at here is pi over 6, pi over 6. Okay, the reference angle we have, pi over 6. Okay, if I just flip this to the next, to quadrant 1 here. All right, so we're still in the same sort of an idea here, okay, except now we're in quadrant 2, okay, rather than quadrant 1. Quadrant 2, what is the SIGN of secant here? right? Remember, it's all students. So sine is positive. Secant is the reciprocal function of cosine, so it's going to be negative. Okay, so we need -2 root 3 over 3 because we didn't have to change anything else. Okay, so we're just going to have -2 root 3 over 3. Okay, so we should be okay with that. So let's go on. What do I have to do here? We have, I don't want to do that. I want to do this one. 990 degrees. Thanks. All right. Okay, we need the reference angle. So one way we could do this is to start figuring out, like, how many rotations did we have? So that's minus 360. We could take 360 into 990. Okay, I can't do that off the top of my head. So, oops, what do we do? Okay, everything is messing up right now. So we have 360. No, I'm sorry, we don't want that. We want 990 divided by 360. It's 2.75. So 2.75. So 360 is a whole way around. So this actually is minus 360. And what are we going to end up with? Okay, so we have 990 minus 2 360s. What, 360s? So we end up with a 270 degrees. Okay, where's 270 degrees? Well, there's 90. There's 180. There's 270. Okay, so that's 3 times 90, 270 degrees. What is the sine of this value down here, right? And it's on one of the axes, so it's either 0 or 1. Sine is measuring the y value, so it's 1 or negative. It's -1. Okay, so sine of 990, -1. All right. Vertical distance, that's all we're measuring with this. Okay, no rationalizing anything with this one. As hard as it's going to get for these? Let's find out. So let's see, that is going to be 360 or 1170 divided by 360. 3.25. All right. So this is, oh, yeah, it is going to be that easy every time. Okay. So it's going to be 1, 2, 3 times around. So we're going to take 1170 minus 3 times 360, because we've already accounted for the 3 revolutions and we have 90 degrees left. So sine of 90 degrees, the vertical distance, it's +1. Okay, so in this case, +1. Okay, hopefully you guys get different angles so you don't have to do it. Okay, so there we go. Use reference angles again, figure out the exact value. We get 26 pi over 4. So what is 4 into 26? Right, that's, well, 6 times would be 24, right? And then we'd have 2 left over. So remember, this is how many pi's there are. We have to divide it into 2 pi's. So this is 6 is going to give us 2 pi times 3 would be 6 pi times around. Okay. So 1 revolution 3 times is going to be our 6 pi. Okay, so we could break this up and we could say this is 26 pi over 4 is equal to 24 pi over 4. That's 6 pi plus 2 pi over 4. 24 plus 2 is equal to 26. This guy right here, okay, this is our 6. This is our 3 revolutions. All right, and then we have 2 pi more. So we're 2 pi over 4. It's right here, right? That's pi over 2. Okay, what is the tangent of 90 degrees? Well, if we go back up to our little table here, right, tangent is sine over cosine. So what we're going to do is we're going to take our our 1, because that's what sine is 1 divided by so that's undefined. Okay, we're just going to type in undefined there. Don't type in undefined. Click it off of this. That's the only way you're going to get the right answer out of this. Okay, so make sure you click the undefined that they told you was undefined. Don't spell it yourself. They won't like it. Okay, and find two angles for the given condition. Okay, so find two angles where the cosine is square root of 3 over 2, or square root of 3 rather. So let's go down here and make a little chart. Okay, so we have our sine theta, cosine. This is where, like, you're gonna say, well, maybe memorizing the whole thing wasn't that bad. It's always that bad. Okay, so angle. So we have 0, pi over 6, pi over 4, pi over 3, pi over 2. So remember, this is 30 degrees, 45, 60, 90. Okay, sine was 0. This is 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Okay, cosine is 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. Tangent is equal to sine over cosine. You could also memorize that, you should memorize cotangent is equal to cosine over sine. Okay, so what we're going to do is we're going to write down the cosine over sine. So this is going to be 1 over 0. This is undefined here. Okay, this is going to be square root of 3 over 2 divided by 1/2. Okay, how do we do division sign like this? This is square root of 3 over 2 times 2 over 1. So this is square root of 3. I think we found it. Okay, do we need to do more? No, but let's go ahead and just finish this. This is square root of 2 over 2 divided by square root of 2 over 2. This is 1, so cotangent of 45 degrees is 1. Okay, this guy here, this is I'm going to cosine over sine. So this is 1/2 divided by square root of 3 over 2. So this is 1/2 times 2 over root 3. So this is 1 over root 3. But then when we rationalize the denominator, right, we get root 3 over 3. Okay. And then finally, cosine 0 divided by 1, which is 0. All right. So here's our values for cotangent. Cotangent doesn't happen often enough to memorize this. Okay, in like trig classes, they'll make a big deal about it. You have to memorize all of this. But you know, of all the times, like I almost always use tangent. Okay, even if I use 1 over tangent, I still used to use 1 over tangent rather than cotangent. Okay, cotangent just doesn't see a lot of use. So if you're compelled to say, I need to memorize all of these, you can safely, as long as you can get tangent, 1 over that is going to be cotangent. So you can work through it. You don't have to memorize these values. Okay, these technically you don't, because you got a phone in your pocket at all times and you'll never have to worry about it. But you want to impress your engineering teachers, your physics teachers, you will know. Okay, when they ask you some of these questions, you'll know. Okay, at least the 45, because in engineering, that one occurs all the time. Okay, so we have pi over 6, right? Angle, so cotangent of pi over 6, that gave us the square root of 3. What are we trying to do? Okay, we want that. Express your answers in radians, don't use decimals. Okay, find two angles where that's going to be true. Where's tangent positive? all students take calculus. Tangent is positive in the third quadrant. Pi over 6 is one angle, whose reference angle would be pi over 6 in the third quadrant. All right, so let's find out. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, 7 pi over 6. That's the one we want, okay? So 7 pi over 6 will have the reference angle of pi over 6. So 7 pi over 6 and 7 pi over 6, those are the angles that we want, okay? So all I did was like, I know it's a weird question to ask. Whose reference angle is going to be pi over 6? We just count them around, okay? Or you can say, oh, pi over 6, third quadrant, we're just going to add pi to it because I need to add 180 degrees, all right? That would also work. So we're going to have pi over 6 for first quadrant. We need third quadrant, so that's 7 pi over 6, and that should be good. All right. So there we go. Last one here. Okay, given, oh, look at that. Given that cosine 8/17 again. Okay. So I just did the 8, 15, 17 triangle, so we don't have to worry too much about the arithmetic, but we will go through it. So given that cosine is equal to 8/17, but it's in quadrant 4, okay? Which things are positive in quadrant 4? Only the cosine is. So the sine and tangent here are both going to be negative values. So what we have, right, is we have a triangle that looks like this. Here is our 8, right? Here's our, right, x is positive here. And then we have 17 here. We need to figure out what is this side. So we have 17 squared minus 8 squared is equal to, let me not jump that far ahead. All right, we have a squared plus b squared is equal to c squared. A squared is going to be 8 squared plus b squared is equal to 17 squared. That's always our hypotenuse, right? So we have b squared is equal to 17 squared minus 8 squared. Can I just take the square roots and do it that way? No, you cannot. So b squared is equal to 289 minus 64. So what do we end up with? We end up with 5, 2. B squared is equal to 225. So b is equal to 15. All right. So when I draw my triangle, I probably shouldn't draw it that big. Right, we have our triangle. We have 8. We have a negative 15 here, right? Because it's in the fourth quadrant. Pretend that's straight. 17. Okay, so here's the angle we're looking for. What's the sine of this angle? It's opposite over hypotenuse. What's the tangent of this angle? It's opposite over adjacent. Okay. Can you rearrange this thing so you can look at it in like standard position if that's what you're more comfortable with? As long as you remember your, where you are. Like, what did that hurt? Okay, it didn't hurt anything. So if you're really attached to like seeing a triangle in standard position and this bugs you, that I get it. Okay, but as long as you label them correctly, you're going to arrive at the right answer here. Okay. So we're going to say, what is this? This is going to be negative 15/17. So negative 15/17. And really? And what are we on here? We are on 15/8. Negative 15 over 8. Opposite over adjacent. Okay. Here we go. Opposite over adjacent, 15/8. And then that's it. Okay, so I will leave the rest of this to you guys. Okay, I know there's lots of problems, but for these look like At most there's 6 steps because there's 6 trigonometric ratios. Okay, and it's mostly just getting yourself used to where things are on the problem. I recommend drawing a lot of pictures. If you're stuck on something, draw a picture. It'll help you immensely. Okay, so I'm going to stop us there, and then we'll put together the next one. All right. Good luck.